have someone truly wonderful to introduce, Alishba Imran, who is a blockchain and machine learning developer from the Knowledge Society and has worked on AI enterprise solutions. She has also worked on an application alongside IBM to track medication in the supply chain using blockchain. I'd like to welcome Ishba. Thank you.
Awesome. Thank you so much for that introduction. I'm so excited to be here. And so yeah, as Natasha mentioned, I'm 17 years old and I'm particularly really passionate about this industry within energy storage. And so throughout this presentation, I'll kind of be talking about what I think the future of energy looks like, specifically the energy storage industry, talking about some interesting frameworks and models in this space and potential ways we can actually accelerate this. And so you might be thinking like, why energy storage? And I think it's a huge problem that not a lot of people are currently focusing on. So I also want to highlight, the impact of this problem and why I think it's such a pressing one. So before I get into that, I wanted to quickly introduce myself. So I'm Alishba, I'm 17 years old. And for the past 2 years, I've been part of this human accelerator program called the Knowledge Society. And through this program, I've gotten training and exposure to some really cool technologies like machine learning, blockchain, quantum computing, and thinking about ways we can use these to break down complex problems and potentially solve them. So throughout my journey, like Natasha mentioned, I've got to work on a platform with IBM. And the goal there was to basically put an end to counterfeit medication within the developing world. And I got to build out an infrastructure to track that medication and supply chain. This past summer, I was interning at TD Bank, which is one of the largest banks in Canada, working on various different AI enterprise solutions and thinking about new product lines for digital identity. And recently, I was working with Pingme, where I was helping them a little bit with their COVID application, as well as helping them build out data tools for loans for people in Africa. So I know I talked about a lot of different problems, but if I had to break it down, I think right now the problem that's really keeping me up is this problem of energy storage. And I'm currently working on this platform with a team called XVolta, and we're basically using machine learning to test energy storage devices much quicker. And so we're currently in talks with some really big manufacturers in the space like AVX, Maxwell, to potentially pilot this out for their company and hopefully make an impact. So later on in the presentation, I'll also be talking about this problem and exactly what our solution entails of. So this picture right here is a picture of a town in India. And 3 years ago, I remember this moment very distinctly. The government had announced that they were to power the town purely on solar panels. And so as someone who had just heard about clean tech and renewables and solar energy, I was personally super excited about this. And I also had family that was living in this town. And so when I was visiting them 3 years ago, I was really excited to see what it was like to live, in a home that was completely powered by solar panels. But reality is this is more of what the town looked like. Throughout the day, there would be power outages for 2 to 5 hours. And a lot of the families there would have like backup generators that they'd be using to generate electricity because there wasn't enough for the entire day. So what I realized was, okay, solar is exciting and it seems like, it's something that we want to move towards, but reality is it's not reliable today. And so clean tech, it's super exciting, but reality is it's not feasible today. So I wanted to break this down further and really understand what this problem is and why isn't clean tech, fully feasible today. And what I found was really interesting. So this graph here shows at a high level what our energy consumption is. And so within the last 25 years, our global energy consumption has almost doubled. And it's predicted that within the next 25 years, it's also going to double. But there's a huge problem of demand versus supply. So there's a lot more demand, not enough supply and production of energy. And this is why 1.2 billion people around the world still have no access to reliable energy. And the key here is really reliable energy. Because if we look at, renewables specifically, they're not reliable today. Like the sun is going to shine more during certain parts of the day. It's going to shine less, let's say during the morning and less towards the night. And so really what we need to figure out is how do we sustain this for a long period of time? And you might be thinking, okay, don't we already have energy, storage systems that are doing this so that we can use renewables throughout the day? But reality is that we don't have enough. Because if we want to reach our goal of 45% of our power being generated from renewables by 2030, we need to almost 20x our energy storage capacity. And based on how we're moving today, that's not going to be enough because a lot of the innovations happening within this space are actually within batteries. So a lot of us might be familiar with that. But I really like this quote by Bill Gates that talks about batteries and why they're not enough today. And so essentially he says, if you wanted to use one battery to store enough electricity to run everything in your house for a week, you would want to get a huge battery, and then it would also triple your electrical bill. And so what this says is, okay, batteries are what we're relying on most today, but they're super expensive and it's not feasible to actually implement these at a really large scale. So I wanted to dig deeper and really understand what are some other interesting areas within energy storage that we're looking at. And what I found was really just batteries. Specifically, areas that people are looking at are solid state batteries, and another one being lithium ion, different materials for lithium ion batteries to improve them. And so when I saw this, a lot of people might be really excited that we're making a lot of progress, but I didn't think we were making that much progress. Because what I think opportunity is often the inverse of popularity. And if we want to make a huge impact, we need to think about solving these problems by looking at opportunities that are currently not being focused on a lot of people. And it's kind of similar with solar. If we thought about solar a couple of years ago, it wasn't necessarily, where it is today. But if we didn't spend time focusing on it and trying to accelerate it, we wouldn't have solar that we have today. And so for me, I wanted to, dive deeper, figure out what are these opportunities that we're not looking at today. And so I wanted to highlight 3 particularly in this presentation that I think are really exciting. One of them being pumped hydro, and kind of new ways we're thinking about pumped hydro because it has been around for a long time. Flow batteries. So this is a subset of batteries that are not as commonly being developed, and I think it has a lot of potential. And the third one is an area that I'm currently working in, and that's within the supercapacitors industry. So at a high level, the way pumped hydro works is it's essentially, you can think of it kind of as just basic dams, and they work in very similar ways. Currently, pumped hydro is around 96% of our world's energy storage capacity, but a lot of these pumped hydro systems were created ages ago. And that's one of the biggest barriers, is that we're not actually creating new pumped hydro systems. But really, the way pumped hydro works is it just uses laws of physics. So if you want to store energy, the water moves up. And so that's like potential energy, which is being stored. And then if you want to release that energy, you move the flow of the water down. And so through kinetic energy, we can basically create and generate electricity. But like I've mentioned, pumped hydro has not really been innovated in for a long time, and they've been around for a while. So there are 3 main reasons why it's difficult to kind of use pumped hydro as they are today. One of the big reasons being that they're geographically dependent. So you need obviously a huge amount of land to build the entire infrastructure and to actually have a lot of water to power the pumped hydro. The second one being that there's large capital costs for dams. So like I mentioned, to build the entire infrastructure, there's a lot of initial upfront costs that you have to put in. And often to actually get approval to build these, it can take like 10 plus years because there's, the economics doesn't always make sense. And there's a lot of legal stuff involved in terms of getting approvals for this. But one company I found really interesting, this is a company called Energy Volt, and they're essentially using the model of pumped hydro, but they've kind of flipped the framework for it. And how they've done this is they basically replaced the aspect of pumped hydro of water with concrete and just bricks. And so that takes away a lot of the geographical barriers that we have because you can really take the system and place it anywhere. The other benefit is because they're bricks, they're a lot heavier, which means they can actually store a lot more energy. And so essentially how this works is it's a crane that's filled up with, as you can see, these bricks of concrete. And so if you lift a block up, that stores the energy, again, kinetic energy. And then if you want to release that, you drop the brick down. And the system is fully charged, you could say, when the crane has like fully filled up with towers of brick. And so this is an interesting model because I think it achieves the exact same goal, but it's a lot cheaper to implement, and it's a lot more feasible in terms of not having the geographical and a lot of the legal and economics not making sense. The other area that I wanted to talk about quickly is flow batteries. And I think this is really like the underdog of batteries, because there are some people looking at this, but I don't think there's enough. The concept is very interesting, but at a really high level, how it works is it's made up of two tanks. So one tank is negative and the other tank is positive. And essentially you have ions moving from the positive tank to the negative. And that's all fueling this battery here. And so once the battery becomes fully charged, the way that the ion moves basically reverses, and that helps generate electricity. So you're charging up the battery, that's storing your energy, and then when you want to release it, the ions go the other way. And so this all works through any sort of source. So let's say you have solar, you have wind power. It takes that electricity from there and stores it for times when you would need it. But there's also obviously barriers to flow batteries, which is why they're not, being used today. Some of the ones being the actual control system costs are very high. So, when you want to release electricity, how much you want to release. All of these systems that are controlling that, there's a lot of initial costs that you have to put in to do that. The other one being that the mass is relatively high. So we've heard about like lithium ion batteries. Those kind of easily go into your phone and they work really well for portable applications. But this really only works for grid scale because the mass is really high. And the actual fluid that you use within the tanks can often also be expensive, sometimes even corrosive and toxic. But there are other kind of materials that you can use to replace this. And so this is one area within flow batteries that I think is interesting. And there's a company called RET Storage that's working on actually deploying these around the US for grid scale solar panels. And so through using this new material, you can essentially have unlimited storage capacity because you can change the size of the tank to really whatever, and then that would increase the storage capacity. There's less degradation that happens, so less, and as a result of that, there's less corrosiveness and less toxins that are being created in the environment. And this system also costs significantly less. And so it's a lot more feasible to actually implement at a grid scale today. And lastly, I wanted to talk about supercapacitors, which I think could be called the next batteries, but I think the intersection of these supercapacitors with batteries is very interesting. Supercapacitors, they essentially look something like this. So they look very similar to batteries. The main difference is that batteries work through chemistry, but these supercapacitors work just through transferring, electrons. And if you look at this graph here, on the right, it kind of compares where supercaps are with batteries. The main area that we need to increase is how much energy these capacitors can actually store. Batteries today can store a lot more than these supercapacitors, but there are some innovations in material science that are helping kind of increase that energy storage. So within the next 5 years, we could see something like some sort of hybrid between batteries and supercapacitors that I think could be very feasible for these types of applications. So I got really interested in supercapacitors, and I decided to really go deeper into the value chain. And as I broke down the value chain of supercapacitors, what I found was very interesting. A lot of the time in the value chain is actually just spent on research and development and production. So this will be anywhere from like 3 months to a couple of years, where companies are just testing how long the cell will last in like various different conditions. But they're doing this manually. So they'll manually connect and disconnect a cell to see how long it'll last. And this process can take a really long time. And that's why it ends up being a huge kind of bottleneck to production and commercialization. So if we can solve this problem, we can help commercialize a lot more of these supercapacitors around the world. And so that's kind of the problem that my team identified. And that's why we're working on X-Volta. And so what we figured out is companies like these are already collecting a lot of data during these tests. So if we can just take this data and feed it into a machine learning model, we can actually just predict the final lifetime and extrapolate that rather than having to do these tests manually. And so through some of our results, using past data, we can actually reduce the time that it takes to test storage from 3 months down to just 3 days. So if you have a batch made up of a bunch of cells, we can reduce that significantly by around 96%. And if you look at this graph here, it kind of shows what that prediction looks like. So you can imagine this as being kind of the past data of the cell. And this is kind of the prediction that we're able to make with a high amount of accuracy. And so this is what we're currently working on. And I'm super excited to continuously, hopefully use this to make an impact in this industry. So I wanted to end off with these three things, because I think, I talked about a lot of different problems, a lot of different areas that I think are very interesting in this industry. But really what I think we need is more people focusing on these three main things. And these three things are, identifying problems or sub-problems within this industry that have a social but also an economic incentive. So in this case, economic incentive being able to democratize solar or renewables around the world. And then also focusing on sub-problems that currently there's not a lot of innovation in. And I really believe in this because I think there's a lot of opportunities where we almost kind of forget about them because there isn't as much noise around them. So really being able to identify those and then doing the analysis to see if this is something that could make an impact in the world. And the last thing I think is that intersection of problem identification combined with using your unique knowledge and skills to solve the problem. And not just solve the problem as what it is, but really breaking it down to understand what is the root cause that is causing this problem. So within Supercaps, when we broke down the value chain, we realized that that problem is actually testing. And so how do we tackle that? Not just the problem of Supercaps as a whole. And I think if these are the three mindsets that we continuously train, we can actually move towards a future where we can start to see clean tech being used around the world feasibly and reliably. And so I think with this, in the future, it's not just clean tech is exciting, but I think clean tech can also be feasible. And if we start to work towards, the 3 points I mentioned, looking at these interesting areas, we can finally reach a point where we can start to have a clean future for everyone around the world. That's it for me. If you guys do want to connect, I just left my my info here. So feel free to connect in whatever way you have. If you have any questions or just want to bounce off ideas or have any other thoughts, then feel free to reach out.
Thank you, Alishba. Thank you very much for your talk. I think you are tackling a very pressing issue and and a problem that is actually affecting a lot of, especially developing countries out there. And I've seen a lot of discussion in the community, and actually a lot of the talks were around the negative externalities of renewable energies, right? So one being the land use for solar panels. How can they claim it back, or how potentially it could be used for agricultural use? And so how do we fix that problem? Another set of negative externalities, of course, involves the disposing of batteries, and how do we deal with that? So I'd like to hear your thoughts on this.
Yeah, I think those are two kind of areas just within renewable energy that I think are probably two of the barriers. But I think it's interesting because there are a lot of interesting companies that are looking at frameworks that still use this idea of solar, but do it without having to use that much land, for example. So there are companies, I don't remember the name of the company, but there was one that I was looking at using quantum dots, which is a part of solar nanotechnology, which essentially helps kind of improve solar panel efficiencies. And instead of having to create solar panels, they actually just created a spray that you could put onto your window. And through this, you'd be generating and absorbing the sunlight, but also generating electricity. So I think there are some interesting frameworks and ways we can combine other technologies like nanotechnology, stuff like that, to potentially remove the barrier of land, especially. So I think that's one interesting area in terms of the first point you mentioned. The second point about battery recycling is another huge point. How do we do it in a way that's sustainable and not hurtful to the environment? I haven't seen, personally, I haven't seen too much innovation in this space, but I do know there are some companies that are looking at ways you can reuse batteries. Most of the common innovations are in ways that we can increase the life of batteries, so you don't have to actually deteriorate them as quickly. So looking at different materials to increase the life. There are companies looking at ways you can reuse batteries instead of having to obviously degrade them. So the recycling process is improved. So from my understanding, I think those are some two kind of interesting avenues that we could take instead of what we're currently doing.
Thank you. And how about optimizing grid distribution, like such as microgrids? Wouldn't it be a better approach than improving storage capacity?
Mm-hmm. Yeah, I think they're both big problems. I think especially in rural areas, like getting access to energy is a huge one, and I think that comes down to just access to grid. But I also think like there could be other interesting frameworks instead of a grid. Like obviously microgrids are interesting, but is there a way we can create something that's scalable and plant these onto homes separately instead of having a grid? So I think there are some interesting kind of ways we can think about it rather than having a full grid system. But I do think there are two separate problems, and both of them require like focus. So we need to solve the problem of grid, especially microgrids in the developing world. But then I also think, even if we solve that problem for renewables, I still think we need to crack like energy storage. And without that, it's going to be hard to fully be able to use renewables. And so I think there are two problems that we both need to focus on.
I've seen questions about solid state batteries. Do you have an opinion, or do you know anything about it?
Yeah, so I've looked a little bit at solid state batteries. I think they have a lot of potential today in terms of being able to use them as common batteries instead of lithium ion batteries. But like I mentioned, I think flow batteries is another area. So I don't know whoever asked that question, but I would definitely look a little bit into flow batteries as well. I think there's a huge opportunity there to kind of innovate, especially within the space of improving like the different types of fluids that you're using within the tanks. So ones that are less expensive and less toxic to the environment. And I think if we can solve that, we can use this, at a very large scale for grid systems around the world.
One of the main topics that is often discussed when it comes to renewable energy is, of course, nuclear energy. And we obviously made it more safe now. It's not as dangerous as it used to be. What's your take on it?
Yeah, I think nuclear energy is an area I haven't looked too much into it. I think it has potential, but I also think there's other areas that could work really well as well. Like one of the interesting areas that I'm interested in is just like fusion energy. I think fusion energy has a lot of potential if we can figure out how to sustain that energy for a long period of time. And so that's like another area that I would look into. Personally, haven't looked too much into nuclear, but I think like the application of fusion at a similar scale to nuclear is very interesting.
Yeah, there was actually a question about fusion energy and fusion power, but I think you addressed that already. So thank you. What are your views about global warming and energy? Specifically, we're talking about fracking.
Yeah, I mean, I think I personally think that I think we need to move away from that, just because of all of the problems with global warming. I do think there's ways we can. Obviously, it's a huge industry, and I don't think it's going to go away anytime soon. I think it's like something that we'll have to progress towards. But yeah, I do think like renewables is the way to kind of move towards this. So in the future, I don't think we'll necessarily need to do that, but I do think like currently fracking is the way to go, and it's kind of it's the common way that we're doing this. But in the future, I think we'll move away from that and move more towards a fully renewable future.
Do you think that would ever happen?
Yeah, I mean, I think that's like a complex problem because there's a lot of like, I think just renewable in itself, there's a lot of problems within it. So I think there's like part of the problem is just like policies and like the laws that we have around renewable sources. I think we need like more government intervention, at least when it comes to renewables, and like more kind of, yeah, definitely we need more of like more of government leaders speaking out about renewable sources and trying to set goals for themselves to implement this. So I think there's more of a policy problem there. Outside of policy, I think there's also a problem of just like the energy source itself and making it more efficient. So how do we make solar conversion more efficient? There's a lot of interesting areas, like I mentioned, in nanotechnology that we can use to increase that. So different materials, improving the efficiency so that it makes sense to use solar. And I think that the third part of that, or I'd say 3 or 4 is like grid. And then the fourth one would be the actual energy storage. So I think those are some key areas we really need to figure out to move towards renewables.